In this video, I'll be applying Newton's second law of motion to solve this question. The question is taken from the motion of bodies that are connected together. It's an advanced level question taken from A-level mechanics and also from university mechanics. And it's a very good practice question for those of you that are offering mechanics in year one, in the university in year one. Now the question says a wagon of mass 500 kg is towed by another wagon of mass 900 kg at a uniform speed, means constant speed. Now if our resistance to motion is expressed in terms of Newton per kilogram, resistance to motion, meaning that for 1 kilogram mass of the wagon, the resistance to motion is 2 Newton. And then you can, of course, be able to calculate the resistance to motion for the 500 wagon mass and also resistance to motion for the 900 wagon mass. Okay, so this one pulls this one with a force F. It will be that this one is broken down, right? Now, let's say we should find the pulling force F. So this F is called the pulling force. Find the pulling force F of the 900 kilogram wagon. Then we're also to find the change in the pulling force, assuming the two wagons now accelerate at the rate of 4 meters per second squared. Okay, so you can see the question now. I want to do a free body diagram of each of these wagons. Okay, so let me move to this side now and draw for the first wagon. The free body diagram shows all the forces acting on the object. That is, this is my wagon A. I can divide this rope into two. Okay, so this is the 500 kilogram mass. Now the frictional force acting against motion is this. Let's call that Fr. Fr, that's the static frictional force acting. That's the dynamic frictional force acting against motion. So that's for wagon A. Then for wagon B, okay, let me just place it below here. This wagon B, I want to draw the forces acting. Now you can see that the tension here is the same for Newton's third law of motion. Because if I cut this rope into two, I have this. So wagon B pulls A with force T, A pulls B with the same force T to obey Newton's third law of motion. So this is my 900 kilogram wagon. Okay, so this becomes my force F. Now I still need to note that frictional force also acts. Let's call that Fr, opposing the motion of the 900 kilogram wagon. So let's calculate the frictional force in each case. In the first case, the frictional force Fr is given as 2 times 5. We can see that now. That is 1000 Newton. Because frictional force is now dependent, is now expressed in Newton per kilogram. So for 500 kilogram mass, the frictional force opposing the motion is this. And for this one, it is 1800 Newton. Okay? Now let's apply Newton's second law of motion for wagon A. Resolving along, because the motion is along the x direction. Okay, so let's say the motion of the wagon. So some of the forces acting along the x direction. So summation of all the forces we have, I can decide that for my coordinate system, any force acting to the right is given a positive sign. Any force acting to the left of the x-axis is given a negative sign. Okay, so I have for Newton's second law of motion, the tension minus the frictional force is equal to mass times acceleration. But here the question says, if you come back to this question, it says that the resistance to motion, if you come back to this question, it says the two wagons are moving with a uniform speed. That means the acceleration is zero. When the speed is constant, there's no acceleration, okay? That means T minus Fr is equal to 0. It means that the tension in the string is equal to the frictional force opposing the motion of wagon A. That is 1000 Newton. Okay, that's my T. Okay, now For the second wagon B, let's write the forces acting along the x direction. So this one is acting to the right, I give it a positive. This is to the left, I give T negative. Frictional force act to the left, I give it negative sign. So the resultant force is F minus T, which is the tension, minus the frictional force Fr equals mass times acceleration. Okay, where A is 0 again, because the two wagons move with a constant speed. I have F minus T minus Fr is equal to 0. That means my force F, which is the pulling force, is T plus Fr. That gives me, I've already found my tension T here. It's the same tension, 1000 plus 1800. That gives me total force of 2800 Newton. Okay? Alright, so that is the pulling force that is coming from the 900 kilogram wagon. Okay, the second question, the change in the pulling force, assume the two wagons now accelerate. Okay, that's the B part. For the B part, since there is now acceleration, we'll go back to the first equation. For the forces acting on wagon A, I have T minus Fr equals NA. My force T is equal to MA plus Fr this time around. Now, since the acceleration is 4, it means the tension in the string is 500, which is the mass of A, times 4 plus the frictional force, which remains the same. That is 1000 from here. Okay? Now that gives me 2000 plus 1000. So I have a total tension of 3000 Newton. Okay? That's the force that acts along the rope, along the string that is attached to the two wagons. Okay? Now we want to find from the second equation of motion. Let's also apply it to the second wagon. The force F minus frictional force minus the tension equals mass times acceleration. Okay? So we have that we have already found our T here. So that gives the force F equals MA plus the force of friction plus tension in the string. That gives you 900 times 4 plus our frictional force remains 1800 plus the tension which we have got as 3000. That is the value of the pulling force F. Okay, so let's apply the calculator here so that I can have my pulling force F equals 3600 plus 1800 plus 3000. That will give me a total force of this is 6600 plus 1800. That will give me 8400 Newton. That's the value of the pulling force F that is applied through the 900 kilogram wagon. Okay, the next thing is for us to find the change in the pulling force. The change in the pulling force is now going to be equal to what? The change in the pulling force is the final pulling force, 8,400, minus the original pulling force, which was 2,800. So that change in pulling force will give me what? When you subtract this from this, it gives you 5,600 Newton. Okay? That's a change in the pulling force on the 900 kilogram wagon. Okay? Alright, so that's how to attempt or to go about this question. So I hope that by next video I'll be able to take more of this.